Okay, today we're going to be learning about geometric reflections. All right, so a reflection is a transformation which flips the figure over a given line. Okay, this line is called the line of reflection. And this line can be any line. It can be the x-axis, it could be the y-axis, or it could be x equals 1. It could be any line. So one of the most important things to remember about reflection is that when you do reflections, you have to make sure that when you transform your image from one side of the line to the other, that it's the same and equal distances away. So you always have to keep in mind it must always be equal distances away. Okay, so we're looking at example 1. It says triangle ABC is being reflected over the x-axis. So you always want to underline what it's being reflected over. Okay? And on your graph, you want to put a line, like a shaded, darker, thicker line over the line you're talking about reflecting it over. So I'm going to put a blue line. Okay, and it says draw and label the image triangle ABC prime. So we're going to reflect that triangle over the blue line, which is the x-axis. So the first thing you need to do is to find your coordinates for A, B, and C before your reflection. So we would write down the original coordinates, okay, and now we have to reflect those original coordinates over the blue line. So we are going to take these and count the same amount of distance on the opposite side of the line. So if you look on the bottom side of the blue line, C is 2 spaces away. So we need to come to the opposite side and make C prime 2 spaces away to reflect it. So the coordinates for C prime would be at 4, 2. And then we'll look at B prime. Okay? Before we can figure out what B prime is, we have to look and see that B is on our line of reflection. If we have a point that's on our line of reflection, it's going to stay the same. Okay? So we can just leave it as 3, 0. And then A prime, if you look, A is 1, 2, 3 spaces away, so we're going to do 3 spaces away on the opposite side of the line. So 1, 2, 3, 1, 2, 3. So this would be A prime. And you should be able to look at your figure and say, if I fold this in half at the line of reflection, then my red triangle would be on top of my black triangle. And that's how you check yourself. Okay? Your coordinate for A is going to be 1, 3. And you guys can also use arrow notations, which down here, when we go to write the rule, in arrow notation, we're going to come up with a rule for this. So in order to come up with a rule, we have to look at the coordinates. We have to figure out, look at your x-coordinates on both. You look at your x-coordinates of the original, and you look at your x-coordinates of the prime. And you say, what stayed the same? And what changed? So if I'm looking at my x-coordinates of the x's, those stayed the same. So the rule can be xy, okay? The x's stayed the same, so we can just write x, okay? But if you look at the y values for both, from the old to the new, you can see that each time these change signs. So it went from -3 to 3. So each time it became the opposite sign. So when you write these geometric rules, we represent opposite by putting a negative sign. So it'd be -y, because the y means opposite. Okay, talking about example 1, it says, tell me more about the figure. Is it congruent or similar? And explain how you know. So we know that this is congruent, okay? It's the same size and the same shape. All right, example 2 says triangle ABC is reflected over the y-axis. So y-axis, that's important because this is a new axis I'm talking about reflecting over. So I'm going to go and I'm going to shade my y-axis a color so I can keep in mind that I'm reflecting it over the y-axis. Okay, so I'm going to take that triangle and I'm going to put down the original coordinates first. Okay, so we're going to write the original coordinates. So A is at 1, -3, B is at 3, 0, and C is at 4, -2. And those are my original coordinates. Okay, now I have to reflect that image over the y-axis. So my triangle should go across this blue line. So I'm going to count how many spaces or how many units it is away from this line right here, the blue line, which is the y-axis. So if you look at A, it is 1 space away from the blue line. On the opposite side, A is going to be 1 space away. So A is now going to be at, or A prime is going to be at -1, -3. So we're going to count how many spaces away B is. Okay, B is not on the blue line this time, so the coordinates are not going to stay the same. We count 1, 2, 3 spaces, so on the opposite, 1, 2, 3 spaces. So and that's going to be B prime. So the coordinate for that is going to be -3, 0. And then for C prime is 1, 2, 3, 4. So 1, 2, 3, 4. And that's going to be C prime at -4, -2. And then this is going to be our reflected triangle over the y-axis. So now we have to come up with a rule for this. So when you find a rule, you're going to look at your x coordinates and you're going to look at your y coordinates and figure out what changed and what stayed the same. Okay, if you're looking at the coordinates from the x's are the opposite. So we're going to put -x. Okay, since the y did not change in the coordinates, we are going to leave it when we're writing the general rule. In example 3, it says draw triangle JKL, which has coordinates J02, K34, L51. So you're going to draw the image triangle JKL prime after a reflection over the triangle JKL over the x-axis. You're going to list the coordinates for JKL prime. So we're going to plot the coordinates of JKL first, and then we're going to reflect JKL over the x-axis. So we are going to draw a line through the x-axis. Okay, when we reflect over the x-axis, as you guys can remember from the rules that we just wrote, that if you reflect over x, you're going to change the y values as a general rule. So we could do this by counting the number away from the x-axis. Okay, like for instance j prime, you would count that j is 2 away from the x-axis, so it would be 2 away from the x-axis on the other side, and that's how you would do it using the counting method. Or we can just recall that the rule for reflecting over x is just changing the y. So if I look at these values over here, you're going to keep all of your x's the same. So 0, 3, 5 would be the same. And you would write the opposite of the sign of the number for y. So instead of 2, it would now be -2. Instead of 4, it would be -4. Instead of 1, it would be -1. So if you look at j prime, you can see that the rule does match, because when I use the counting method, j prime is also in the same position. So now I would just plot the rest of my points. 3, -4 for K, and L would be at 5, -1, L prime. Then for part D, it says draw the image triangle JKL prime prime after a reflection of JKL prime over the y-axis. So now I'm going to reflect my green triangle over the y-axis. So I'm not going to do anything with my original triangle, which was the black triangle. I'm going to take the one that I already reflected, and I'm going to reflect it again over the y-axis. So now I'm going to count the spaces away from the y-axis. So because j prime is on the y-axis, it's going to stay the same. So j prime prime would have the same coordinates. And we put prime prime because it's being reflected twice. So every time a transformation is performed, you're going to put a prime symbol for that number of transformations that have occurred. So you can also use the counting method for reflecting over y, or you can also use the rule method, and if you reflect over the y-axis, you are changing the x. So when you reflect over y, you change the x. And this is helpful when you don't have a graph, when they just give you coordinates. So you need to know both methods. So for k prime prime, if I look at k prime and I reflect over y, I'm going to change the x. So if I would use these coordinates, I can do k prime prime by changing the x to the opposite, which would be -3, and keeping the y the same, which is -4. And then I can plot that at -3, -4. And we can check this by counting that k prime, 1, 2, 3, is 3 away, and k prime prime is also 1, 2, 3 away. So I can use my rule to find L prime prime. So L prime prime, I'm going to do the opposite with the x, which is -5, and keep the y, which is -1. So L prime prime would be located right here. Okay, part F says describe a different combination of two reflections that would move triangle JKL to triangle JKL prime prime. So it's asking you, how else could we get from the black triangle JKL, the original, to JKL prime prime, which is the red triangle. So we performed a reflection across the x-axis, then we reflected across the y-axis to get to the red triangle. You could also get the same results by taking the original triangle and reflecting it across the y-axis and then reflecting it across the x-axis. So this is just showing you that you have more options and you can get the same results. So from the black triangle, we originally reflected over the x and then reflected that image over the y. But the red arrows show you that you can reflect over the y-axis, then reflect over the x-axis. Okay, part G says, is this new image congruent or similar to the original figure? We have to keep in mind that this is an image that is being reflected, and all reflections stay congruent. Okay, it stays congruent because the shape, size, and angles all stay the same. The only difference is the position. Okay, example 4 says draw triangle ABC, which has coordinates A01, B34, and C51. Alright, part B says draw the image triangle ABC prime after a reflection of triangle ABC over x equals -1. Okay, in order to use this as your line of reflection, x equals -1, you have to look at the x-axis. It's not telling you to use the x-axis as the line of reflection. It's saying at x equals -1. So you're going to find where x equals -1 on your x-axis, and you're going to draw a line through x equals -1. When you perform a reflection with lines that are not x or y axes, the same rules that you had before will not apply. You will have to use the counting method to create the reflection for this triangle. So you're going to use this green line as your line of reflection, and you're going to count the same amount of spaces away on the opposite side of the green line. So if you look at the coordinate A, it is 1 space away. So you're going to find the same position on the opposite side of the green line and plot A prime. So A prime would be at -2, 1. So then for B, you would find B on the same position, and you would count from the green line. B is 1, 2, 3, 4 spaces away, so you would go on the opposite side of the line and go 1, 2, 3, 4. So your new coordinates would be -5, 4. So each time your y value is not changing, but your x is changing. So when you would plot B prime. And then for C, you would do the same. Count how many spaces it's away. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you would plot C prime. And that would be at -7 and 1. All right, example 5 says draw triangle ABC, which has coordinates A01, B34, and C51. So you're going to draw the image of triangle ABC prime after a reflection of triangle ABC over y equals -2. So we're going to underline our line of reflection, and we're going to find where y equals -2 on the y-axis. So you're looking at the y-axis and finding where -2 is. So -2 would be right here, and we're going to draw a line through that. -2. So we want to reflect this triangle over the blue line. So we're going to do that by counting the amount of spaces it is away from the blue line. So we can start with A, and since A is 1, 2, 3 spaces away on the opposite side, A is going to be 3 spaces away as well. So we're going to plot A prime at 0, -5. B is 1, 2, 3, 4, 5, 6 spaces away. So on the opposite side of the blue line, 1, 2, 3, 4, 5, 6 spaces away is where we're going to plot B prime. So the coordinate would be 3, -8. So with C, we're going to count from the blue line 1, 2, 3, and then the opposite of the blue line 1, 2, 3. And so C prime would be at 5, -5. Now if you look at the coordinates for your original figure, you can notice that the x values do not change, but the y values change. But you just have to keep in mind that when you have an equation of a line where it says y equals a number, that you're going to use the counting method to figure out where that new position is located. So if it says y equals a number or x equals a number, you're going to use the counting method. When it says y equals a number, that's going to create a horizontal line. And if it says x equals a number, that's going to create a vertical line, which is going to be your line of reflection.